Hi. Welcome to my channel. Monkeys resistant to coronavirus reinfection. Rhesus macaque monkeys. 6 DNA vaccines show promise in animals. Evidence from studies carried out on rhesus macaque monkeys suggests that once infected with the novel coronavirus, the animals may be protected against reinfection. Though early, this is encouraging news that vaccines, when developed, may be able to elicit humoral and cellular immune responses to protect individuals from infection. The team led by Dan H. Perrouch from Harvard Medical School in Boston, Massachusetts published the results in the journal Science. In total, 9 adult rhesus macaques, 6 to 12 years old, were exposed to 2 different doses of the virus. The researchers found high levels of virus in the lungs and nose, nasal swabs. While the virus cleared by day 10 in the lungs, it persisted for as long as 28 days in the nose. The researchers next evaluated different immune responses by animals that were infected by the virus. They found that all 9 animals developed binding antibody responses to the spike protein of the virus, and neutralizing antibody responses too. In addition, antibody responses of multiple subclasses were found. On day 35 following initial viral infection, all the 9 monkeys were re-exposed or challenged with the same 3 doses of the virus. Compared with 3 monkeys that were not earlier infected with the virus, all the 9 animals that were challenged showed very less virus in the lungs on day 1 and no virus on subsequent days. In the case of the nose, the viral load was higher than in lungs but lower than when exposed for the first time, to induce infection. The viral loads in the nose after the challenge showed rapid decline. Little or no clinical disease was observed in the animals following the challenge, they write. What that indicates is that all the 9 monkeys mounted an antibody response to the second dose of the virus, suggesting that immune systems could successfully eliminate the virus and protect the animals. While there is currently no data available in humans suggesting that those who have been infected are protected from reinfection, leading to the World Health Organization to caution against using immunity passport while lifting lockdowns, the results from the animals are reassuring. In this study, we demonstrate that SARS-CoV-2 infection in rhesus macaques provided protective efficacy against the challenge, they write. However, it is critical to emphasize that there are important differences between SARS-CoV-2 infection in macaques and humans, with many parameters still yet to be defined in both species, and thus our data should be interpreted cautiously, they note. Testing DNA vaccines. In another paper, also published in Science, Dr. Perrouch writes, we immunized 35 adult rhesus macaques, 6 to 12 years old, with 6 different DNA prototype vaccines. The animals were first immunized with 2 doses of 5 mg NDA vaccines at weeks 0 and 3. At week 5, the researchers observed spike protein binding antibodies and neutralizing antibodies. The amount of neutralizing antibodies found in the vaccinated monkeys was comparable with the amount seen in a cohort of 9 monkeys that had recovered from novel coronavirus infection and 27 human convalescent plasma. All the monkeys were challenged at week 6, which is 3 weeks after the booster dose. No viral RNA could be found in the plasma of the animals, and the animals exhibited only mild clinical symptoms. The vaccine was able to elicit robust protection in the lungs than in the nose. And 8 of the 25 vaccinated animals did not have detectable virus either in the lungs or in the nose at any time point, when exposed to the virus following vaccination. Protection was likely not sterilizing but instead appeared to be mediated by rapid immunologic control following challenge, they write. Our data suggests that vaccine protection against SARS-CoV-2 in macaques is feasible, they note. There was a dramatic reduction of viral replication in both the upper and lower respiratory tract with the optimal vaccines. They say that it is possible to protect against lower respiratory tract disease compared with upper respiratory tract disease. This is exactly what was seen in the case of the Oxford University vaccine trial results on monkeys, too. The monkeys did not develop pneumonia but were infected with the virus in the upper respiratory tract. In the present study, optimal protection was achieved with the full-length S immunogen in both the upper and lower respiratory tracts and reduced protection when the vaccine contained soluble constructs and smaller fragments. Please save the trees and nature. Please subscribe my channel. Thank you.